So in this session, let me give introduction for partial fraction, right? Of course, there are many models in our partial fraction. Now, what is the main motto of our partial fraction, especially in our control system? I'm just giving introduction, guys. Already I told you. In signals and system, we will see the in detailed explanations, right, about the control system, that is about Laplace transformation and its applications, right? Everything we will see there. But in control system point of view, which are the things that are most important, we should revise all those things, right? So already we saw the basic properties of our Laplace transformation, right? Anyway, in this session, we are going to keep our concentration with our partial fraction. Why? Because converting the values from time domain to signal domain, that is S domain. We saw what we are going to do in our Laplace transformation. Of course, some signals are there. That signals should be present in time domain, right? Now, for our EC analysis, we are going to convert that signal, right? For our EC analysis, to know the behavior of the system, we are going to convert the signal from time domain to S domain. Once it will be converted, then after completing the analysis or after completing the what I can say, some equations that we are going to get in S domain, then we have to reduce the equations, right? Reduce பண்ணதுக்கு அப்புறம் again நம்ம என்ன பண்ணணும், we have to getting back, right? Actually we are living in time domain, right? S domain is, it's not my home, time domain is my home, right? But in my home now I don't have some facilities to analyze the properties, so I'm shifting my place, right? I'm just going from this point to that point, I'm roaming there and I'm standing in S domain, I'm sitting in S domain for a long short duration, and whichever the things that I want, I'm just collecting, and then I have to getting, that is which is my permanent place, time domain is my permanent place, so I have to get back here, right? So what I'm going to do now, so first we are in time domain, we are in our home, and then I'm going to convert it into S domain. So when the moment after completing all the things in S domain, I have to get back to my home, right? To get back, getting back in the sense, I have to once again shift to my place from S domain to time domain. Time domain is my home, S domain is not my permanent home, right? So in S domain, with the help of some reduction technique, after completing all those things, I have to once again apply some things, some properties, so that my signal allowing me to shift my place once again from S domain to time domain. So that is called partial fraction. So actually partial fraction enna pannu appadina, when we have more number of poles, like I will tell you now, I will let you know what I mean by poles and zeros at all. When we have more number of poles, if I have more than one poles in the denominator of a transfer function, we will see what do you mean by transfer function, what do you mean by poles, what do you mean by zero. I will tell you all these things, right? But don't be panic, whichever the term that I am using, slowly inject, right? So I'm slowly injecting the poison, right? Slowly into your mind, slowly slightly, right? Okay, some terms are there, they are called poles in our control system. If you have more number of poles, if you have more than one pole in my system, in such a case, in the denominator, in the S domain, if you have more number of poles, more than one pole in a system, right? In such a case, to bring that poles property from S domain to time domain, we are going to use partial fraction. When we have more number of poles or more than one pole lying in the system, in such a case, to individually to obtain the individual responses, right? Individual person's responsibility. For example, pole is a person. When we have more number of people, like I have 2 people or 3 people, 4 people, what I have to do, partial fraction is going to help fast to separate them, right? So this person, like that we have to separate them, and then you can convert them individually. You can convert the responses from S domain to time domain. So that is the beautiful application of our partial fraction, right? Okay sir, that is over. Now just if I am going to keep some terms here, right, and I will let you know how to apply partial fraction. Later I will explain about those terms, right? What do we mean by poles, what do we mean by zeros and all, right? Now in partial fraction, first of all, listen, simply I have a function like this. Listen, just I have a function like this. Blankly listen here, right? Sir, I am not getting what you are trying to write here. Okay, no problem, just listen here what I am trying to do, right? Blankly I have a function like this, like in the denominator of a function, like I have 10 by s plus 1 into s plus 2. I have some function like this, right? Now in the S domain we are living here, right? In the S domain we are living here, right? Now we know how to get some functions from time domain to S domain, right? You know how to travel from time domain to S domain. Now what I am going to do, once again assume this is my system. This system has been completely analyzed. In my temporary place, I was sitting there and I was analyzing the entire property of the system. Now my work is over. I would like to get to my, that is, I would like to getting back to my permanent place, my home, right? For that, we are going to apply partial fraction. This is my system. After analyzing the complete property of a system in S domain, we are going to apply partial fraction. Now, how to apply partial fraction? Listen, guys. I have a function here. Just observe the denominator of your function. Always keep your attention with the denominator of your function. ஒரு ஃபங்க்ஷனுக்கு நீங்க partial fraction apply பண்ணும்போது keep your attention with the denominator of your function, right? Now here I have a function. In my denominator I have some people. How many people are there? Person 1, person 2. Total I have 2 people, right? If you have, just go to the denominator, keep your concentration with the denominator. If I have 2 persons here, then assume there are 2 arbitrary constants. That property is going to be 2 arbitrary constants, right? Now I am going to break these 2 persons into 2 categories, right? That is integer responses. இங்க ரெண்டு பேர் இருக்காங்க, பட் அவங்க ரெண்டு பேர் denominator எப்படி இருக்காங்க? ஒரே வேல்யூல இருக்காங்க, right? If 2 people are mingled together, can you analyze them separately? No. I would like to know the integer behavior of this person, integer behavior of this person, such that in time domain your analysis will become very easy. Sir, I have 10 people. Individually I know each and every person characteristics. Like you can control. Sir, I have a class. 10 people are there. Like if I say like that, can you know the property of the 10 persons directly? No. So for that, I am breaking them with the 2 arbitrary constants, and then keep the corresponding values in the denominator. Don't think about the numerator. Whatever the values that is lying in the numerator, just leave it. Just should try to go to the denominator. Observe, identify the number of persons. If 2 persons are there, then consider 2 arbitrary constants. Then in the denominator, correspondent pole. For arbitrary A, correspondent pole is s plus 1. For arbitrary B, correspondent pole is s plus 2. Next, your target is, so first step is you have to identify the number of poles while applying partial fraction in S domain, right? And then if 2 poles are there, then assume 2 arbitrary constants. Then I will teach you how to calculate these arbitrary constants. Now in the next step, right, that is the first step. This equation should be equal to this one, s plus 1 into s plus 2. We can write like this. It can be rewritten like this. Now in partial fraction we have to estimate the value of a and b. For that, take your a equal to, assume this overall function can be written as f of s. Overall function can be written as f of s. Very simple. Now a is equal to, take your overall function once again f of s and multiply it by correspondent pole. Getting me? A is the arbitrary constant. I would like to know the value of a. Now to obtain the value of a from this transfer function, take your overall transfer function, multiply it by correspondent pole. Correspondent pole here, s plus 1 is the correspondent pole of arbitrary constant a, right? And then after completing, இப்போ இந்த f of s ஓட வேல்யூ நீங்க அப்படியே சப்ஸ்டிட்யூட் பண்ணி ரெடியூஸ் பண்ணதுக்கு அப்புறம் replace s by, that is c. This is my correspondent pole, right? இந்த correspondent pole ஆல மல்டிப்ளை பண்ணிட்டு இந்த pole ஓட வேல்யூ, right? You have to always pole will be equal to 0. I will tell you the reason why your pole is equal to 0 அப்படிங்கிறதுக்கு reason நான் சொல்றேன். First you should remember, always your poles will be equal to 0. Slowly inject, okay? Poles will always be equal to 0. And then I will tell you another reason, right? So pole will always be equal to 0 such that if s plus 1 will be equal to 0, then s value will become minus 1. First thing, right? So what I am saying here, I am just equating it to 0, I am getting s equal to minus 1. So what I am doing here, to identify the value of a, I am taking overall transfer function and multiply it by correspondent pole, right? And then you have to reduce பண்ணி முடிச்சதுக்கு அப்புறம் எங்கெங்கலாம் s இருக்கோ அந்த s க்கு பதிலா நீங்க என்ன சப்ஸ்டிட்யூட் பண்ணனும் அப்படினா, இங்க a க்கு ஆர்பிட்ரரி கான்ஸ்டன்ட், இந்த ஆர்பிட்ரரி கான்ஸ்டன்ட்டோட போலோட வேல்யூல ரிமைனிங் இருக்கிற டேர்ம்ல சப்ஸ்டிட்யூட் பண்ணனும். சார் என்ன சொல்ல வரீங்க? see, let me control f of s. This is my overall transfer function, 10 upon s plus 1 into s plus 2, right? And it will be multiplied by s plus 1. Now see there, s plus 1 getting cancelled out, whereas the value of s is going to be minus 1. எந்த arbitrary constant choose பண்றீங்களோ அதோட denominator இருக்க போலோட வேல்யூ தான் இங்க நீங்க சப்ஸ்டிட்யூட் பண்ணனும். கேன்சல் பண்ணதுக்கு அப்புறம், right? Now 10 divided by, I have a term is called s. Wherever you have s, after reducing, after cancelling these functions, in the final step, wherever you have s, replace all s by minus 1, its correspondent value, right? s க்கு இங்க minus 1 போட்டீங்கன்னா minus 1 plus 2 will become equal to the value of 10. So the value of a is going to be 10. Next, what we are going to do, in the same way, again calculate the value of b. Now how will you figure out the value of b? Now to estimate the value of b, once again take your overall transfer function. Overall transfer function is 10 upon s plus 1 into s plus 2 f of s. That is the overall transfer function, and I have to multiply it by its correspondent pole. B oda correspondent pole s plus 2, and then after reducing the function, s will be replaced by minus 2. That is the correspondent pole of B, right? S plus 2 getting cancelled out. Now here s will be replaced by minus 2. So 10 upon minus 2 plus 1, that will become minus 1. Minus 1 into 10 will become minus 10. Once you find the value of arbitrary constant a and b, you can play a role. It's a small mathematical tool. See that how beautifully it is helping us to identify the value of arbitrary constants. And at the same time, see that initially two people properties had been mingled together. Now those properties has been break separately such that now you can develop further. Now take this overall transfer function, right? So here this is my transfer function, right? This can be rewritten as this overall function can be written like this. Now here the value of a is going to be 10 upon s plus 1, and the value of b is going to be minus 10. So minus 10 upon s plus 2. Next thing is, take your 10 outside. 10 is arbitrary constant. 10 is a constant. We cannot do anything with that, and you can take it outside. Now what I have? 1 by s plus 1 minus 1 by s plus 2. That is how we are applying partial fraction here to break the terms. அதுக்கப்புறம் நீங்க என்ன பண்ணணும்? Now once you break the terms individually, now see that person number 1 is separated from person number 2. Now you can take the inverse Laplace. I hope you all remember in our last lecture what is e power minus at. Laplace of e power minus at u of t can be simply rewritten as 1 upon s plus a. Now what we have understood from here, if the value of a equal to 1, then here you will have s plus 1. If the value of a equal to 2, e power minus 2t into u of t, that can be written as 1 by s plus 2. Now the thing is, in s domain, wherever you have 1 by s plus 1, s domain la 1 by s plus 1 irundha, in inverse Laplace it can be rewritten as e power minus t into u of t. So let me take the inverse Laplace. Inverse Laplace of 1 by s plus 1 can be written as e power minus t minus inverse Laplace of 1 by s plus 2 can be written as e power minus 2t into u of t. Why the signals were multiplied by u of t? U of t is a signal. It will helping us to keep all our signal in the first quadrant only. In our Laplace transformation, I have been clearly given the definition, right? U of t is a step signal. That signal will going to travel from 0 to infinity only in the first quadrant. If I have some other signal, that signal is coming from time domain, that is second quadrant to first quadrant. But in our control system, we are assuming that the initial value is always 0, right? You have to start from the origin. This is my present moment. Past will be neglected always. Now to neglect the past, to ignore the past, always your all signals will be multiplied by step signal. Why? Because step will exist only in the first quadrant. In the second quadrant, value of step is 0. If I multiply it by 0, இப்போ நீங்க உங்களோட சிக்னலை ஸ்டெப்பால மல்டிப்ளை பண்ணீங்க அப்படினா 0 into this value become 0 in the second quadrant, whereas in the first quadrant value of step is 1. So 1 into anything only. So to restrict my signal only in the first quadrant, your signal will always be multiplied by a step signal u of t, right? So that is how we are applying partial fraction in the method number 1. Similarly, if I have repeated poles, right? If I have repeated poles, then what is the procedure to obtain the value of correspondent poles, right? That is correspondent, how to break the poles, right? Let me explain once again. Not a big thing, but you have to understand, right? That is not a very big deal, right? To understand. Listen, for an example, sir, I have a same signal 10, but in the denominator I have s square into s plus 1. Now how to apply partial fraction for this? See, once again, when we are forcibly applied to, that is when we are forcibly requested to apply partial fraction, when we have more people in the denominator. So if I have a single person, then we can simply take the inverse Laplace. If I have more people, then we are unable to characterize the persons individually. For that, we are going into partial fraction once again. That is very simple, right? So once again, what we are going to do, when the moment I am applying partial fraction, identify the number of people in the denominator. See that s square in the sense, at one point we have two persons. So when inga two persons irukanga, idhula one person irukanga, totally we have three people, right? So while applying partial fraction, you are supposed to go with three people, right? For a1, that is arbitrary constant a, and then take your arbitrary constant b, and then keep arbitrary constant c. Next, what I would like to do here, sir, of course three people are there, but always listen. Repeated poles vandadha appadina, for example, if s square varudha appadina, you have to consider two arbitrary constants, right? Now in the denominator of the first arbitrary constant, in the denominator of the first arbitrary constant, you should start up with the minimum order. That is not with the 0. Minimum order means you should go up with the minimum order 1 storage element, right? S power 1, and then you have to travel up to the maximum order. Second person, in the denominator of the second person, you can keep the second, that is s square, and then you can keep in the third person, in the denominator of the third person, you can keep s plus 1. So what we are trying to do? Very simple. Listen, if I have 1 by s cube, then this function can be written as a by minimum order is s power 1 for this. Don't start from s equal to 0, you have to go up with the minimum order, right? So s power 1, and then it can be written as b power, that is b divided by s power 2, and then c divided by s power 3. It's a mathematical tool. Procedure is like this, right? Suppose if I have 1 by s power 4, then that can be written as a by s power 1 plus b by s power 2 plus c by s power 3 plus d by s power 4. That is the generalized procedure to obtain the value of various arbitrary constants. Clear? Okay, sir, I understood. This is the procedure. Now getting back to my system, I have only two poles, right? So it can be written as a by s power 1 plus b by s square plus c by s plus 1. Now here the problem is to find out the value of a only, right? Why? Not a big problem, but you have to understand. Now last case and the procedure, this method will be slightly different from the previous one. Slightly different, right? Slightly different in the sense, what I would like to conclude here, slightly different in the sense, listen, how to find out the value of a. To find out the value of a, you are supposed to differentiate this overall transfer function dnt f of s with respect to ds after cancelling its highest order as s square, and then you can replace its s value. S square அப்படினா s அப்படிங்கற s square அப்படினா s ஓட வேல்யூ 0 தானேங்க. s plus 1 அப்படினா இப்போ s square நீங்க டைரக்ட்டா என்ன பண்ண முடியும்? 0 க்கு தான் ஈக்குவேட் பண்ண முடியும். Suppose if I have s plus 1, அது நீங்க 0 க்கு ஈக்குவேட் பண்ணும்போது you will get s equal to minus 1. Like if I have only s, in the sense that pole will be placed at the origin. அது 0 ல இருக்கு, origin ல இருக்கு, right? Anyway, sir, here we have so many confusions. Yes or no? ஒண்ணுமே இல்ல. Listen, arbitrary constant a வந்து நம்ம இது procedure. Step number 1 நீங்க என்ன பண்றீங்க? s square இருந்தா minimum orderல இருந்து ஸ்டார்ட் பண்ணி எழுதுறீங்க. ஆனா நம்ம என்ன பண்றோம்? a ஓட வேல்யூ கால்குலேட் பண்ணும்போது you have to go with originality. Originality in the sense, anyway, for our mathematical tool we are going like this. But by finding the value of a, what is the original order? Actual order is s square only. அப்ப நீங்க actual order தான் இங்க கன்சிடர் பண்ணனும், right? By applying actual order in s square, okay, this is differentiate பண்ணனும். Why? Because actually what we have 1 by s, the term is 1 by s, but what is our order? Our order is s square. Our order is s square. அப்ப என்னோட original order வரணும் அப்படினா I have to differentiate once. To get the actual order, I have to differentiate this function once. 1 by s differentiate பண்ணீங்கன்னா you will get minus 1 by s square. See there, I am getting my original order. Then after getting the original order, you can substitute the values. Are you getting me? Suppose if I have a by 1 by s cube னு இருக்குன்னு வெச்சுக்கோங்க. அப்ப இது எப்படி எழுதிப்பீங்க? a by s b by s square plus c upon s cube அப்படி நம்ம எழுதுவோம். கரெக்ட்டா? In such a case, actual order is s cube. அப்ப when the moment you are finding the value of a, this is overall function f of s. This is overall function f of s. இத நீங்க எத்தனை டைம் டிஃபரன்ஷியேட் பண்ணனும்? 2 times you have to differentiate this function with respect to s square. With respect to s, you have to differentiate 2 times, and then you can multiply it by correspondent highest order is s cube, and then you can substitute the value of s equal to 0. Similarly, to find out the value of b, already s square irukka, actual order is s cube. So one time I have to differentiate. To obtain the actual order, one time you have to differentiate and then multiply it by its original order. Actual order is s power 3, and then substitute s by 0. After completing the procedure, you can substitute. That is the actual procedure. That is very simple, right? Now in the same way, for my function, my actual order is what? S power 2, but here I don't have original value, so for that I am doing one time differentiation. Now take your overall function 10 upon s square into s plus 1, right? Anyway, we are going to differentiate, but எப்ப நீங்க differentiate பண்ணனும் அப்படினா first you have to cancel the order, right? First you have to cancel the order. இந்த s square ஆல denominator term cancel பண்ணதுக்கு அப்புறம் next step you can proceed, right? 10 is the arbitrary constant. 1 by s plus 1 நம்ம differentiate பண்ணோம் அப்படினா what will you obtain? S plus 1. Actually we have 1 by s plus 1. இத நம்ம எப்படி எழுதலாம்? S plus 1 whole inverse. If I differentiate this function with respect to s, d by ds into s plus 1 whole inverse can be written as, நமக்கு என்ன தெரியும்? x power n differentiate பண்ணா we will get n into x power n minus 1. Differentiation of x power n with respect to x. So what we are going to apply here in the same way, if I differentiate this function with respect to in the same order, this is my n, that is going to be minus 1 into s plus 1 in the power n minus 1. N value is minus 1, minus 1. Minus 1, n value also minus 1. That is become minus 1 into s plus 1 whole power minus 2, or it can be written as minus 1 by s plus 1 whole square. So d by d, that is d by ds into 1 by s plus 1 can be written as 1 upon minus 1 into 10. Actually it become minus 10 divided by s plus 1 whole square. Now you can substitute the value of s as 0. But in s is 0 substitute it will become minus 10. So the value of a will become minus 10. Now to calculate the value of b and c, that is very simple. See, why sir? See, b or a correspondent pole s square, that is the actual root. So you don't need to do any differentiation, right? To obtain the actual root, we don't need to do any differentiations, right? We can simply find out the answer, right? Now in the moment I am talking about these things, to obtain the value of b, take your overall transfer function f of s, multiply it by correspondent root. See, this is my original order, given order. If my order will be redundant, right? If I have a redundant in my order, if my actual order is not being placed here in partial fraction, when you have repeated poles, then definitely in minimum order la dhaan start பண்ணுவீங்க, s power 1 la dhaan start பண்ணுவீங்க, then you can go up to maximum order. Actual order வரும்போது நீங்க எந்த பிரச்சனையும் இல்ல, லாஸ்ட் மெத்தட் நம்ம என்ன பண்ணுவோமோ அதை அப்படியே அப்ளை பண்ணிக்கலாம். ஆர்டர் வந்து கம்மியா வந்தா மட்டும் ஒரு டைம் டிஃபரன்ஷியேட் பண்ணனும் வித் ஒரிஜினல் போல் only. ஒரிஜினல் ஆர்டர் தான் நீங்க இங்கே கன்சிடர் பண்ணனும், பட் one time you have to differentiate to obtain, to equate it with the original one, right? So anyway, in this case actual, to obtain the value of b, overall transfer function into s square, actual value, this is actual value only, in the into, and s is going to be what? 0. So next what I am going to do, f of s is what? 10 upon s square into s plus 1 into, we have to multiply by s square, whereas the value of s is going to be 0. S square getting cancelled out. Now replace s by 0 such that the value of b also going to be 10. In the same way, c is going to be, c oda order of s plus 1 correspondent pole, right? So and once again consider the overall transfer function into correspondent pole is s plus 1, of course, whereas the value of s is going to be minus 1. In the s oda value da ipo neenga consider pannum, correct? So the overall transfer function is 10 upon s square into s plus 1, and I have to multiply it by s plus 1, whereas the value of s is going to be minus 1. S plus 1 getting cancelled out. S க்கு பதிலா minus 1 substitute பண்ணீங்க அப்படினா minus 1 whole square will become plus 1. So which is equal to plus 10 only. After finding the value of ABC, getting back a value is 10, that is minus 10. A value is minus 10 by s, plus b value is how much? Plus 10 by s square, and c value is how much? C value is plus 10. So plus 10 by s plus 1. Now we can take the inverse Laplace for the given function, right? Now we can take the inverse Laplace for the given function. So what I would like to conclude from here, so here inverse 10 is constant, inverse Laplace of 1 by s. Yesterday what we saw, step signal, if I take Laplace for step signal you will get 1 by s. So 1 by s can be replaced by, value of a is minus 10, minus 10 is arbitrary constant, 1 by s can be replaced by step signal u of t, right? Second signal, once again 10 is constant, 1 by s square. Yesterday what we saw, Laplace of t, t into u of t, t into u of t. I can write like this, t into u of t can be written as 1 upon s square. So second case that will be replaced by 10 into u of t. Third one, once again 10 is arbitrary constant, plus 10 is arbitrary constant. What we saw, Laplace of e power minus at, what we saw in our yesterday class, because in e power minus at into u of t, right, and its corresponding Laplace can be written as 1 upon s plus a, right? If the value of a is going to be 1, so that will become e power minus t into u of t such that its Laplace is going to be 1 upon s plus 1. So what is the conclusion? 1 by s plus 1 can be replaced by e power minus t into u of t, e power minus t into u of t. Clear? Now see there, that is how we are taking, how we are obtaining the inverse Laplace transformation of a transfer function from s domain to time domain. Getting me, right? So that is the second model of our partial fraction. I hope you all have understand this procedure, right? How to apply partial fraction. Of course some two more models are there in this method. That things we will see in our sequencing system, because this is the introduction only, right? So just I am giving introduction for Laplace, because my control system, right, my entire art of the control system, it's only beginning, right? So it will going to be analyzed with the help of Laplace transformation only. For that I am giving introduction for Laplace transformation, right? We are not going to analyze the Laplace here, we are going to analyze our control system with the help of Laplace, right? So this much of things are sufficient here. And apart from this, I hope you all remember in our last lecture I I told you e power minus at into sine omega t. Into sine omega t, of course it will be multiplied by u of t. To keep my signal only in the first quadrant or from the initial value. E power minus at into sine omega t, in the sense, don't forget the formula is omega upon s plus a whole square plus omega square. Very very important formula. In the same way, suppose if I have plus here, then here you will get minus. That is also very very important. Similarly, if I have e power minus at into cos omega t into u of t, in such a case, your formula can be written as s plus a upon s plus a whole square, s plus a whole square plus omega square, because I am going to use this formula also. This is also very very important. Should try to keep these things into your mind, right? Because that is very very important. Suppose if I have plus here, then here it is going to be minus, s minus a, s minus a. Clear? So this is all about partial fractions, right? So with this we will start our what I can say control system, right? So in our control system we are going to categorize our systems and we are going to discuss about our transfer functions and all, right? So I hope you all understand, right? Well, doubts you can ask in our comment section, that is in our group, right? Thank you.